Hey Dominic, Joe just said you want to know why metal rusts in water. Well, by rust, I'm assuming you're talking about when certain metals turn orange and flaky. This is a process or reaction that happens to a metal called iron. Specifically iron is what makes that color. It happens because the reaction is when oxygen attacks the metal. Now this attack can only happen in the presence of water, which is why you mostly see it happen when metal, iron things, steel and chains and Titanic, get dropped into the water. Now this process needs water to happen, but it also needs some other things, which is why in salt water, things rust and break down even faster. Now, I don't know if you know, but the air all around us is full of moisture, which is water. That's why things can rust even if they're not underwater, but they're just sitting outside. But you notice it doesn't happen as fast as if they're actually in the water or in salt water. So hopefully, I'll be able to show you a couple of little demonstrations in this next video, and I'll be able to highlight what's going on. Now, other metals don't rust like iron does. They have different properties. They will either turn white and not orange, or they won't react to whatever's going on at all. So you're going to see that there are a couple other things. So let's see, for example, copper turns green and forms a shell called a patina, which is sort of like rust, but it stops. It actually protects the metal instead of hurting it. And things like aluminum, well, it's really hard to get a reaction out of that with just water, which is why your Coke cans are made out of aluminum, and you almost never see rusty Coke cans. You'll see soup cans because they're made out of steel. Now, what I've got is a stuff called steel wool, which is iron or steel that has been spun and stretched out into little tiny threads that are thinner than your hair. The hairs in your head, this stuff's even thinner, but it's still pure metal, pure steel, iron, and steel. So what I'm going to show you is that's a perfect way to demonstrate. So the first tube has nothing but regular old water in it. Now eventually the iron would break down and you start seeing rust. The second tube has salt water in it. Again, you'd see the iron break down, but it would take much quicker than the plain water. Now, remember how I said earlier that it takes water, salt, and oxygen to make the rust happen? Well, in the third tube, I've got some special water that has extra oxygen in it, some salt, like salt water, and you'll see what happens. And then in the fourth tube, we just had a little fun, and we've got some really cool stuff to drop in there. And then the rest of the video is just other things getting dropped into other tubes. Like Chocho always knows, I go a little overboard, so you should have some fun with this. Alright, I'll talk to you later. Have a good trip, everybody. I love you, and I'll see you guys hopefully soon. Okay, Dominic, so as you can see here, I've got a couple of different tubes set up. This first one is just tap water. So I'm going to put the steel wool in the tap water. And as you can see, not a lot of reaction. Now, given enough time, that would eventually start to rust and break down, but it would take days or weeks before we see anything. Frankly, we don't want to wait that long. Now, remember how I said salt water makes it break down faster and you get rust faster, like on Titanic? Well, let's put a little bit of steel, the iron, inside the salt water, and no reaction right now. Now, given time, the salt water would have rusty stuff forming much faster than the regular tap water, but they would both make rust eventually. But remember how I said that it takes oxygen and salt and you expedite the process? Makes it go faster, much faster? Well, I happen to have some special water that contains extra oxygen, and I've mixed that with a little bit of salt water, and we'll see what happens if we put extra salt and extra water, oxygen together with the wool. Oh, as you can see, it's already starting to bubble. There you go. All those little reaction things, that's the oxygen attacking the steel and the iron. You see the color coming off already? That's what we're looking for. Now, in this tube, ooh, that spilled. Okay. In this tube, now, always safety first. I've got my big rubber gloves on. We're going to have that same salt and that same special water that has extra oxygen. But this time, we're going to add a very strong acid known as concentrated hydrochloric acid. Now this is going to react much faster because it's got all kinds of special properties. But this one will not just make the steel rust, it'll actually dissolve it completely. Like when you put sugar in your tea, the sugar goes away. Look how fast that's going. That is steel, iron, and it is just being eaten away like nothing. Now, when I said this stuff was strong, I'm not kidding. But because that acid is only working to eat the steel because of the presence of the salt and the extra special water. So what I've got here is it's got some regular laboratory water. It's got nothing extra in it. It is just pure water. I told you this stuff was strong. I'll show you how strong it is. See if you can see that. Right here, it's actually fuming. There are fumes coming off. Let me see if I can make them happen a little more. Anyway, if you can see it, it's fuming hydrochloric acid. Very strong stuff. So I'm going to put that into the water. And for future reference, you always put acid into water, not the other way around. Because if you put water into acid, there is a very good chance that it'll have a very violent reaction that's not good. So, we're going to take that same wool, steel wool, and we're going to put it in with just the acid and the water. See? Without the extra two special ingredients, you're going to have a little bit of bubbles forming a little bit later, but nothing very spectacular. You need all the extra things. See, look at this. You've already got rust forming, big piles of it. And this is what that stuff will look like in a little bit of time. Here is what it looks like after about 15 minutes. And then after about a half an hour, after 30 minutes, it's nothing but little particles. And that was just the extra special water and salt. The extra special water and salt. Oop, wrong one. There we go. See? It's just breaking it down and making straight rust out of that steel. Now, other metals will react differently depending on what their properties are. So let's see what happens. Ask Chocha. I like to go overboard on a lot of things. So we're going to take this same special super strong acid that's not doing much with the iron and the steel, but this time we're going to add it to a couple other kinds of metals that I have here in the lab. Oof, I just got a whiff of those fumes of the acid. It's pretty strong. All right, so remember, we're going to go water, super strong acid. Now, let that sit for a second, mix it up really well. Now what I'm going to put in is a screw. Just a regular building screw, something that a lot of people are familiar with. It's galvanized, meaning that it's been coated with a special metal called zinc. Now zinc, in the presence of water, doesn't rust, and it doesn't break down like iron does and steel does. However, in the presence of very strong acid, it starts to bubble and dissolve. But it won't make that traditional rust color like you see from the steel and the iron, because that is a very special property of iron. This is just going to dissociate actually, but so it's just going to break it down and it's going to form kind of a white substance. So when that is the same process as this, it's just doesn't make the same rust color. Now there's one other substance that is known to react very well, and that is regular rolled aluminum foil. Now aluminum, the reason why it's used in a lot of things for like soda cans and stuff is because it does not react well with, it doesn't react to water. However, so it doesn't rust for your, you don't have a rusty can of Coca-Cola. So I've got a little ball of aluminum foil here, but what it does react to is hydrochloric acid. In fact, it reacts quite violently at times. Let that sit there. Now, aluminum, in the presence of air and water, it forms a little bit of a coating, and it kind of protects itself in similar terms of copper, in terms of making a patina. But as the acid starts eating through the aluminum, and it breaks down, it's going to start heating everything up, and you'll see that it's going to kind of bubble up here in a little bit. You can see that nice rust forming right there. Now let's see what happens. I've got another kind of acid that's also very, very strong, and that is called sulfuric acid. And can you see that? You can't see that. So let's just shift everything over just a little. That is the concentrated hydrochloric. We're going to put that to the side. This is sulfuric acid. Let's see what happens if we drop some other things in there. So, copper, they make pennies out of it. They also make wire out of it because it conducts electricity very well, but it reacts differently to the other metals when you put them in acid. So, for example, in hydrochloric acid, no reaction. What about if we put it in sulfuric acid? Again, no reaction. To get copper to do anything, to dissolve and to dissociate like this stuff is, you would need a substance called nitric acid, which, frankly, I don't have any of that on hand, so it's kind of hard to get. However, in this, which is the special water with extra oxygen and salt mixture, the steel has gone bubbly and it's pretty much broken down into a big pile of rust. But down here at the bottom, about half an hour ago, if you can see that, I put a little bit of, there you go, I put a little bit of copper in there, copper wire, and it's bubbling a little bit because it's reacting with the oxygen just like the steel does, but very, very slowly. It's because it's a very stable metal and it doesn't like to do much. Now, what the other thing we can try and do, you remember this zinc that dissolves? Let's see what happens. Well, let's see. Does zinc react to sulfuric acid? Honestly, I can't remember. Pretty sure it does, though. Not very much. Not at first. But it's starting to bubble away. Let's see. Does aluminum react in sulfuric acid? Again, yes, but not very much. So we'll leave those guys to sit there for a minute. Let's move some of the tools out the way. Now, let's see, we've got our concentrated hydrochloric acid back. Let's see, in just straight up acid, what happens to the foil? Press it down a little bit so it fits. Let's see, it's starting to break down. That's the thing. In this form, it's so concentrated that it doesn't like to react very well. But there you go. Just took a second to get started. See, when the aluminum breaks down, it turns into a blackness. Boom, just like that. Let's see, let's drop some more zinc in there, see what happens. Does it react just as well? Hey, look at that. It's bubbling right away. All right. Now, let's go with one more experiment to see what happens. So, I'll leave that to bubble. Let's see if I can make some room here. So I've got just plain water in there for now. I'm going to add some more fuming hydrochloric acid. And as you can see, I'm putting the acid into the water. That should be nice and strong. Now we're going to see what happens when we use different kinds of metals. First of all, I have no idea. This is a nickel. And it's called that because it's actually made of a metal called nickel. Does it react to sulfuric? Nope. Hydrochloric? Nope. It's pretty stable. It doesn't like to react to much. But what happens if you, say, have metals that are made out of two kinds of metals together? Like this American penny. On the outside, the penny has copper. But I've scratched it away a bit, and on the inside, you can see that silvery color, that's zinc. So let's see what happens if we leave these in our acids. I'll just let that run for a little bit, and we'll see what happens. Ooh, we got some stuff going on? A little. So eventually what you're going to see is that acid is going to eat all the way through the zinc, but leave the copper there, and you're going to have an empty shell of a copper penny. And you know what? Why not? Let's just throw some more steel wool into some of these guys. Throw another one there, because why not? It's fun. So we'll let those run for a little bit, and we'll check back. Well, eventually, that aluminum foil, it just started breaking through, so I decided I should probably start recording that. And it is now reacting to the hydrochloric acid in quite a bubbly manner. I'm just going to keep putting steel in here, see how much we can dissolve. And that stuff's going away just super quick. You can see here, with this special extra water, all you get is a big pile of rust building up right at the top of there. The salt water, not much is going on. Tap water, almost nothing. What else can we drop in acid to see what happens? Yeah. You look down here, you got a little bit of bubbling action going on both of those metals, and we will check back in a minute. Okay, I just want to let you watch the reaction go on that because it's just cool. And after about 45 minutes, the other tube that was just the special water and salt, the steel has been completely turned into a rust powder that is just in solution at the bottom of the tube. Nothing else is going to happen because all that steel is now gone and replaced with rust, which is technically referred to as iron oxide. These are all making different kinds of chlorides and oxides and fun stuff. That's bubbling away. We'll check back later.